Chapter 4 is about integrals, and this section, 4.1, is called areas and distances. And it's basically an introduction to what integrals actually are. So question 3 says, estimate the area under the graph f of x equals 1 over x from x equals 1 to x equals 2 using 4 approximating rectangles and right endpoints. Sketch the graph and the rectangles. Is your estimate an underestimate or an overestimate? And then part B just says repeat part A but using left endpoints. Okay, so the first thing we're going to do is just sketch it to see what's going on. So let's do that. If you'll remember what a 1 over x graph looks like, I'm just going to draw it from 0 to infinity because it's the part that we're interested in. It's going to look something like this. And they're asking us to calculate the area from 1 to 2. So I'm going to exaggerate. Imagine this is up to scale. Okay. There's going to be 1, there's going to be 2. And we have to draw 4 rectangles. So I'm going to do that. Okay. So notice that our rectangles are going to have, so their base is just going to be 1/4 of the distance from 1 to 2, right? So this one right here, this is going to be 1/2. 3 over 2. It's going to be 1.5, right? This one right here is going to be 1.25. And this one right here is going to be 1.75. So actually the distance, the base of all the rectangles is just going to be 0.25, which is 1 over 4. And now they're asking us to do this using the right endpoints first. So I'm going to draw this. Actually going to duplicate the graph first so I don't have to draw it twice. Okay. So part A is saying use the right endpoints. So we're going to do this. And part B says to use the left endpoints. So we're going to draw it like so. Okay. Now just looking at this, we can see that part A is going to be an underestimate and part B is going to be an over, right? So I'm going to write underestimate and overestimate. Okay, but the base is going to be the same for both, right? So delta x is just going to be 0.25, which is 1/4. They're going to be the same. Now, how do we actually calculate the area of the rectangles? Well, this is just basically adding, we're going to add the area of 4 rectangles and calculate the total area that way. So let me move this out of the way. Oops. I'm going to redraw the 4 rectangles because I think it's easier to see. So this is the first rectangle, it's going to be 1 over 4. And the height is just going to be, this point is going to be the function at 1.25. It's just going to be f of 1.25. The next rectangle is still going to be 1 over 4, but the height is going to be at f of 1.5. Third rectangle is going to be 1 over 4. And f of 1.75. And the fourth rectangle, 1/4, and f of 2. Right? So the total area, I'm going to just say A, is going to be equal to f of 1.25 times 1/4 plus f of 1.5 times 1/4 plus f of 1.75 times 1/4 plus f of 2 times 1/4. We can take the 1/4 out and rewrite it this way, which is usually what people do. What should I do? I'm going to move these. Plus f of 1.75 plus f of 2. Okay. And let's actually calculate this. It's going to be 1/4, and then we're going to plug in 1.25 to our original function, which is 1 over x. So that's going to be 1 over 1.25 plus 1 over 1.5 plus 1 over 1.75 plus 1 over 2. And if we put this into our calculator, we're going to get 533 over 840. And let's actually calculate this in a decimal so that we can see what's going on. This is going to be 0.6345, more or less. Okay, so this is going to be the answer for part A. Fractions are always better, but if you put it in a decimal, that's fine too. So now let's calculate this again for part B. I'm going to draw the rectangles again because I think it's helpful. So this is going to be 1/4, and now our height is going to be f of 1. That's going to be our first height. Second rectangle, 1 over 4, f of 1.25. Third rectangle is going to be 1/4, and then f of 1.5. And the last one is going to be 1/4, f of 1.75. So our area is going to be, I'm going to put the 1/4 outside because we already know that it's okay. So it's going to be f of 1 plus f of 1.25 plus f of 1.5 plus f of 1.75. And we just plug this into our original equation, which is 1 over x. We're going to get that, and if we actually calculate it in our calculator, we're going to get 319 over 420, and that's going to be approximately 0.7595. And actually this is basically, if you didn't notice from the sketch, we can see that the first one is going to be an underestimate. This is going to be smaller. This number is going to be smaller than this one right here. So the first one is going to be an underestimate, and the second one is going to be an overestimate. But we can see that they're very similar. So the actual value, the actual value of the area underneath this curve from 1 to 2 is going to be between these two, more or less. And that would be your answer.